So then, group. What is a group? A non-empty set G together with a binary operation is called a group if it has to satisfy the four conditions, four axioms. First one is called closure axiom. What do you mean by closure axiom? For all A comma B belongs to G, then we can say A star B is also belongs to G. Then only we can say it is closed. Okay? So if you are going to a provision store, there will be getting sugar and also there will be getting a coffee powder. In the same provision store you will be getting an instant coffee. Similarly, that is said to be the closed one. Here there is an element in A in G, there is an element B in G. The binary operation of A star B is also in G. Suppose in a natural number we are taking 2 and 3 under the multiplication. 2 belongs to natural number and 3 belongs to natural number. The multiplication of 2 and 3, that 6 is also belongs to G. Then we can say that is N comma star is the closed one. Here, therefore, if you take A comma B belongs to G, then A star B also belongs to G. Then second one is associative axiom. For all A comma B comma C belongs to G, then A star B star C is equals to A star B star C. This is said to be associative axiom. 3. Next is existence of identity. Existence of identity. Let A belongs to G be the identity element. Identity element exists. Identity element exists. Then such that what is the condition for existing identity element C? A star E, very important property, is equals to E star A is equals to A, where E is an identity element. For all A belongs to G. This is the way to find out the existence of identity element. This is the third axiom. The next one, fourth one, existence of inverse axiom. Existence of inverse axiom. Let A belongs to G. Also, the existence of inverse elements. The existence of inverse element where A inverse is also belongs to G, such that A star A inverse equals to A inverse star A is equals to E. This is the property of existence of inverse element. If all these four conditions are satisfied, then immediately we can say G under the binary operation star is a group. This is all about the group. So if a non-empty set G is said to be a group with a binary operation star, then we can say it has to satisfy all these four axioms. First one is closure, the second one is called associative axiom, the third one is called existence of identity element, and the fourth one is called existence of inverse element. So this is said to be group. Now, abelian group. What do you mean abelian group? A group satisfied with commutative property. Next one is abelian group. So otherwise it is said to be commutative group. Commutative group. So what do you mean by abelian group? An abelian group, a group G satisfies with commutative property. Commutative property is said to be an abelian group. That is, for all A comma B belongs to G, then we can say A star B is equals to B star A. So this is said to be a commutative property. If it holds, a group holds a commutative property, then we can say abelian group. In general, if you find out you have to prove that the given matrix or given thing is a abelian group, then you have to satisfy all the 5 axioms. One is closure, second one is associative, third one is existence of identity element, fourth one is existence of inverse element, and also you have to satisfy the commutative property also. Then the given group is said to be the abelian group. Okay. Next we will pass on to order of a group.